Hello my brothers and welcome to Introduction to Redstone Computer Episode 1. In today's episode, we will discuss popular types of computer architectures, how they work, and what architectures we will be using to build our Redstone computer. So just sit back, relax, and let's get started. First, what is computer architecture? To understand it simply, computer architecture is the design and organization of a computer's components. These components include the central processing unit, or CPU for short, memory, and input and output devices such as keyboard, mouse, and monitor. Computer architecture essentially tells us how to connect these components together to create a functional computer. Now that we know what computer architecture is, we can discuss the different types of computer architectures. The first type of computer architecture is the von Neumann architecture. The von Neumann architecture is a computer architecture that was first proposed by John von Neumann in 1945. The von Neumann architecture is based on the concept of a stored program computer, which means that the program that you write will be stored in the memory along with the data that the computer needs, such as numbers, text, or images. Next, we have the Harvard architecture. The Harvard architecture is based on the concept of separate memory space for instructions and data, which means that the program that you write will be stored in one memory space and the data that the computer needs is stored in another memory space. Finally, we have the Modified Harvard architecture. The Modified Harvard architecture allows for separate memory spaces for instruction and data, but also allows for the sharing of memory between these two. So what architecture will we be using to build our Redstone computer? Taking notes from a lot of previous Redstone computers, I will be using the Harvard architecture to build our Redstone computer because the separate memory spaces for instruction or our programs and data will be much clearer to understand and will make it easier to build our Redstone computer. One thing I also want to mention, which should make you understand what we will be building more, is computer architect's layer of abstraction. The layer of abstraction is a concept that is used to describe the different levels of abstraction in computer architecture. The layer of abstraction is divided into 5 levels. First, we have the application layer, which is the highest level of abstraction and is where the user interacts with the computer, like writing documents, listening to music, or watching YouTube videos. Next, we have the operating system layer, which is where the operating system manages the computer's resources like memory and processing power and provides services to the application layer. After that, we have instruction set architecture layer, which is where the instruction set architecture defines the instruction that the computer can execute. The instruction set architecture is the interface between the hardware and the software, and it defines how the software, like a program written in C programming language, can control the hardware. Next, we have the microarchitecture layer, which is where the microarchitecture defines how the instruction set architecture is implemented in hardware. Finally, we have the digital logic layer, which is the lowest level of abstraction and is where the digital logic circuits are implemented in hardware. What we will be building in this series is the bottom 3 layers of abstraction. So the computer that we will have is just a bare bones computer that can run programs and store data, but it will not have an operating system or application. And that's computer architecture in a nutshell. I hope you enjoyed this episode and also learned something new from this episode. In the next episode, we will discuss the first layer of abstraction, which is the instruction set architecture layer, and we will discuss how to design our instruction set architecture for our Redstone computer. Thank you very much for watching, and I will see you all in the next episode. Have a nice day, everyone.